Hello and welcome. This is Group 19, and our project is the Metadata module. The objective and goal of the Metadata module is to create a system that organizes and stores information about Navy training material in a knowledge graph. This module will connect to the message broker system using RabbitMQ to ensure smooth data exchange between all other modules. The graph database will streamline content tagging and enhance the efficiency of searching through the intricate relationships among various training materials, resulting in quicker and more accurate retrieval of relevant information. Essentially, what this means is we will be going through the Navy's training content and materials and effectively categorizing and organizing it based on the actual contents of the training documents. This will allow to make their training more efficient and reduce the need for time-consuming manual categorization. This is all done through extracting the metadata of the actual trainings and feeding it through our system, which will properly tag and organize it through the database.
Here we have a block diagram of the metadata module. Once the document module completes the summary extraction, it sends it to the parser module where the files are securely stored. The extracted sentences are then passed to the analysis algorithm, which categorizes and labels entities. These labeled entities are sent to the node builder, where they're structured and stored in the graph database. Throughout this workflow, each component provides real-time updates to the status feed via RabbitMQ, ensuring live monitoring in the dashboard module.
Hello, I'm Islam Sadiq, and I'll be talking about our technical implementation. So, when it comes to our system's communications infrastructure, we put significant emphasis on ensuring effective communication between all different modules. And this is primarily achieved through thorough implementation of the message broker system in RabbitMQ. What makes this particularly effective is our ongoing active collaboration with other teams, which helps us maintain smooth operations across all system components. In terms of our data processing and analysis capabilities, we've implemented a sophisticated approach using spaCy for entity and relationship extraction, as opposed to Roberta, which we had previously. This works in conjunction with our integration of the Metadata model as well, which we're using to generate detailed mission profiles for the nodes. The combination of these technologies has been instrumental in enhancing our knowledge graph structure and adding meaningful contextual depth to our data. One of the key benefits we've seen from this implementation is a significant reduction in data redundancy while simultaneously supporting more efficient search and access capabilities across our system. These implementations have been proven to be highly effective in meeting our technical objectives.
So far the things we have completed for the project are the status feed function, which will monitor and provide updates for the status of a job throughout its entire lifecycle. The database operations function, this will primarily create new nodes and relationships, but it'll also keep relations between nodes up to date. We fine-tuned spaCy. This was done by the transfer learning method on a small dataset to increase the accuracy of the model's ability to detect the correct entity and relations out of a document. We've leveraged Metadata for mission profile generation. This adds better context to the knowledge structure of the data so that it provides a better usability and readability to the Navy. We've also set up our infrastructure, which is the localized hosting of Metadata with API calls. This enabled the MLM to be easily integrated into our system, and it will be easier to use in the future for the Navy and other groups that will be working on the same project. The things we have left to do are further fine-tuning spaCy to extract the main node of documents more accurately. This will be done by using a larger dataset to give the model more context to work with. After finalizing the spaCy model, we'll be working to integrate our module components together. And lastly, we will continue working on Metadata to ensure that it extracts accurate mission profiles for the documents given.
Hello everyone, my name is Mohammed and I'll be demonstrating the metadata module for the content creation pipeline. In this presentation, we're going to demo uploading a document to the document queue, then have The document module will extract the summary. Then once the summary is extracted, it will be sent to our analyzer, which is Spacey, a natural language processing model that we train with a small data set to recognize entities and label such entities. So let's go ahead and show you the little data set we created. So basically the data set consists of sentences that typically you would see in a training PDF. This is just something we came up with since we don't have access to the data. So for example, the GE 414 engine is used in both commercial and military aircraft. So what we care about is the GE 414 engine. So we index that. We say from index 4 to 16, this entity should be recognized as a digital twin engine. Now, we have it trained with the word engine in it, but if we had a vast dictionary of data, we could train it on just the pattern. For example, 2 letters followed by a number is followed by 3 numbers is an aircraft model number and so on. But this is just to get the model trained on such a small data set, as ML model requires a lot of the data set that we don't have. Currently, we have about 50 sentences, which is doing okay for our demo purposes. But in reality, you would need quite a lot of bit of data to train this model. So let's go ahead and show you a little demo. So we have our dashboard module running here. We're going to be uploading a document, which is called project for PDF. So let's go ahead and upload that. So project for PDF is about the GE414 engine and the F-18 aircraft, and it's talking about the maintenance of the GE414. So let's go ahead and upload this server. Okay, that has been uploaded to the queue. So it's waiting in the queue. So we're going to run our document module, which will extract the summary and run the process of making the nodes. Okay, so what it did was extracted the summary, then passed on the summary to our Spacey model, which analyzes each sentence and extracted nodes from there. So as we see here, we have the unique nodes as first the learner object was howto.pdf. The name, we just hard coded that for now. Then we have the relationship with the engine. Then we have the node and the engine relationship with the next node here. So let's go ahead and take a look at our database. As we see here, this was the previous as we cleared it out, but the new ones, what we have in our database is just the GE414 engine. It has learner object howto.pdf, and the learner howto.pdf is the learner object of GE414 engine. So we're storing both the relationship bidirectionally. So we're going to go ahead and do another document here. So we're going to do another document that's going to be about ships. So we're going to change this to howto1. Then in the file we'll be uploading is called oneproject4.pdf. So let me show you what that looks like here in a second. So this is about the STFD650, which is a steam turbine engine that powers the USS Missouri. So we're going to go ahead and upload this one. Okay, that's been uploaded. Then, as you can see here, in the dashboard module, it'll actually tell us where the metadata has been stored. So let's right here, metadata has been stored in Neo4j. So let's go ahead and take a look at our document module. Here we have our nodes, howto PDF, marine, and so on. Let's go ahead and take a look at the database. Now we have 6 more nodes, and there we go. We have the USS Missouri, generator DG5000, USS Missouri has engine STFD650, has the learner object howto.pdf. The howto.pdf didn't make change because we didn't restart the document module here. But essentially, this is what it would look like. Instead of pointing at howto.pdf, it would point at howto1.pdf.